about temperature then. Sorry. Like we said yesterday when we were talking about the metric system, the temperature that we as scientists typically will use is Kelvin. Now, when we measure temperature in here, we'll measure it in Celsius, and then we'll convert it over to Kelvin for some of our experiments. Certain things, the math, the formulas require that you're working with temperature in Kelvin. If you don't do it in Kelvin, you won't get the right answers. Okay? But it's a really pretty easy conversion to make. Now, what is Kelvin? What is this system that they have? Well, everything around you right now is vibrating. Okay? Your desk, your backpack, every molecule in this room is vibrating. Okay? If it's a solid, it's vibrating in place. You can't see it. It's tiny. It's on a very small scale, but it's moving. It has some molecular movement. And we measure that molecular movement as temperature. As you cool things down, that molecular movement slows down a little bit and slows down, and you cool it more and it slows down more. If you cool things down all the way to the point where all of that molecular movement is stopped, that's called absolute zero. And that is 0 Kelvin. So Kelvin temperature scale is measuring that molecular movement, how fast that stuff is vibrating. The warmer it gets, the more it vibrates. Everything in here you could eventually melt if you heated it up far enough. Okay? And you make it go into a liquid, and then the molecules are able to float past one another. We'll learn all of that as we move through the year. So, absolute zero is where all of that molecular motion stops. That's really, really, really cold. They haven't actually gotten anything to that temperature. They've gotten close in lab, but they haven't actually gotten there. Anything that you're experiencing in your life is never going to be at 0 Kelvin. You'd be dead. Okay, you can't survive that. Okay. Water is going to freeze at 273 Kelvin, and it boils at 373. So this gives you a perspective of where that's at. So that would be a negative 460 degrees Fahrenheit. It's very cold. Okay. These are the two formulas that you need to have written down. So Celsius equals Kelvin minus 273, and Kelvin equals Celsius plus 273. Now, because Kelvin measures this molecular motion, you can't get any less than not moving. So that's why you can't have a negative Kelvin value. If you calculate a negative Kelvin value, either I've given you a bad problem or you made a mistake. All right. The next thing that we're going to talk about today then is density. And density is the ratio of mass of an object to its volume. We're going to measure the mass in grams, typically. That's what we measure our stuff in lab in here. And our volume is either going to be measured in milliliters or in cubic centimeters. All right. So our formula for density then, our formula for density is, there we go. Density equals mass divided by volume. Because remember, the definition was the ratio of mass to the object's volume. So this is a ratio here. All right. They are telling us up here that we have a brick of salt. They've given us measurements, and then they've given us a mass. So our mass is 433 grams per. Now we've got to figure out the volume. How am I going to calculate the volume for this problem? I have a rectangular object. How do I calculate volume? Remember your formula for that from math class? Length times width times height equals volume of a rectangular object. Do you remember that? So we need to calculate our volume. Our length is 10 centimeters. Our width is 10 centimeters. And our height is 2 centimeters. So I'm going to multiply 10 times 10 times 2. Better do that in their head. What we got? 200. And that's centimeters. We multiplied centimeters times centimeters times centimeters. So that is centimeters cubed. Remember doing stuff like this in math class back in the day? Okay. So now I know what my volume is. I'm going to go back in and I'm going to substitute that volume measurement into my density formula. And I come out with 2.165. Now I need to attach units to this. I'm going to grab my units from over here. None of these units are going to cancel out, so my units become grams per centimeter cubed. And that is density. Now, I want to talk about how we might go and rearrange this equation if we were to ask to solve for other things. If they asked me to solve for mass, how would I get mass by itself? What would I do algebraically to get mass by itself? Right now it's divided. What's the opposite of a division? Okay, so I'm going to reverse the process. I'm going to multiply both sides by volume to get mass by itself. So density equals mass over volume. I'm going to multiply this side by volume, but if I do that, what do I got to do over here? I got to do it to this side as well, right? My volume is going to cancel out. That's going to leave me with mass equals density times volume. Right? Remember that part of algebra? All right. If I want to get volume by itself, right now it's multiplied. What's the opposite of multiplication? Division. So I'm going to divide both sides by density. Density will cancel out over here, and that'll leave me with volume equals mass over density. See how to rearrange that equation? So now we have a formula for solving volume. We have a formula for solving mass. And we have a formula for solving density. Frog in my throat. All right. So tonight, if you didn't finish in class yesterday, your 2-1, I want you to finish that up. We've got measuring sticks. You've got the yarn in the bag. Okay. Tonight's homework then is this 2-2. And I will very shortly have the answer keys for both of these online for you as soon as this video finishes up that I just made.